page 4. These problems are like the problems we've seen before. The only difference is that we see some DMS, degrees minutes, from before, right? So how we put this in our calculator, if you had just 87 degrees, right, you'd make sure your mode's in degrees. But because it says degrees and then it says 43 minutes, you have to hit your second angle button, and you need to make sure after 87 you hit the degree, and then you would hit second angle, and then you scroll down and hit the minute one. And then remember, if you want the seconds, right, if you want the seconds, you have to hit alpha plus, which we don't see here, but just in case you had to use it. Let's create a right triangle. So let's draw one over here. We'll label it A, B, C. C is 90. We know this is little a, little, oops. This is little a, little c, little b. We know that angle A is 87 degrees and 43 minutes. So in here, we know that's 87 degrees and 43 minutes. Now down here then, we can find angle B. We will do 180 degrees minus the other two angles, minus 90 degrees, minus 87, then you have to hit second angle, hit the degree, then you have to hit second, the degree, and then we're going to hit 43, second angle, and we'll click on the minutes, and then we'll hit enter. And then what remains is angle B. So angle B will become 2.28 degrees. So right now we know that angle A is 87 degrees 43 minutes. We know that angle B is 2.28 degrees, and we know that angle C is 90 degrees. We have that information right now. Now let's find all three sides. They tell us that A is 9.73, so across from big A is little a, 9.73. Now we can't use Pythagorean theorem, we need to use SOHCAHTOA to find B or C, and then we can use Pythagorean theorem. Let's say I decide to find, doesn't really matter. Let's say I decide to find little b. And let's say I'm going to use angle B as my reference angle is theta. So in terms of that theta of angle B, little b would be opposite. 9.73 would be the adjacent side, and C would be the hypotenuse. So if I'm trying to find little b, if I want to find little b, if I'm using angle B as my reference angle, as my theta, I want the opposite of angle B, and I have the adjacent. So what part of SOHCAHTOA will we use? So I want the opposite, so I'm not going to use cos, and I have the adjacent, so I'm not going to use sine. So I want the opposite and I have the adjacent, so we're going to go with tan. So then we'll write the tan of the angle we circled, which is 2.28 degrees, is equal to the opposite, which is little b, side B, over adjacent, which is 9.73. When we multiply both sides by 9.73, we'll get little b is equal to 0.39. So we know little a is 9.73, little b is 0.39. And then to find little c, divide side C, we can just do the Pythagorean theorem, right? So we know that we have let's see what we did. So we did tangent of 2.28. Tangent is opposite over adjacent. And then over here we'll do define side C, so we know C squared is equal to B squared, which we just found, plus A squared. And when we take the square root of all of that, we will get 9.74. So once you have two sides, you can use Pythagorean theorem to find the last. Let's look at number 2. So for number 2, I'm going to draw the picture of the triangle over here. So we'll label this as C. We can call that A, we can call that B. We know that's 90 degrees. We know that we have little b and little c. So little b is across from angle B. So little b is 100 over here. We know that little c is across from angle C, so we know little c is there. We can use Pythagorean theorem to find little a, right? So to find little a, I'm going to write Pythagorean theorem. We have a squared plus b squared equals c squared. And when we solve, we'll get an a value of 438.7. So we have all the sides. Now, if we're searching for the angles, we know that one's 90. Let's try to find one of those other angles. So let's say that I circle A, doesn't matter. And let's say I call A theta. In reference to angle A, over here would be opposite, over here would be adjacent, and this is the hypotenuse. I need to, if I'm going to use part of SOHCAHTOA, I need to work with sides that I have. I can use any part of SOHCAHTOA right now though, because I have all three sides. Let's say I want to work with the adjacent and the hypotenuse, because there's no decimals there. Out of SOHCAHTOA, my pen's gonna get messed up. The pen is kind of messed up. Okay, so out of SOHCAHTOA, if I decide to work with the adjacent and the hypotenuse, I'm going to go with cosine. So the cos of angle A, just write A, is equal to the adjacent side of angle A over the hypotenuse. So then we know angle A is the inverse cos. How does that look weird? We know angle A is inverse cos of 100 over 450. So angle A is equal to 77.16 degrees. And the last thing we need is angle B. But if you have two angles, you can find it the third by subtracting the others from 180. So we can do 180 minus 77.16 minus 90. And so what's left for angle B is 12.84 degrees. And then lastly for page 4, we have one more on this page. So it says an aerial photographer wants to photograph farm property, and his company determines that the best photos are taken at a height of approximately 475 feet and a distance of 850 feet from the farmhouse. What's the angle of depression? So we know that they say the height off the ground should be 475 feet. So we know that this is 475 feet. It says that this plane is going to have a distance to the house. So that's this, going to be the hypotenuse. That direct distance from that plane to the house is 850 feet. What is the angle of depression from the plane to the house? So what do they want? They want the angle of depression. So we're going to take this plane and we're going to do a straightaway, a horizontal line. And then the angle of depression means our line of sight, we swing downwards so that we can see the house. And this angle outside is our angle of depression, right? We know that this angle right here, alternate interior angles, are going to be the same. So that's why down here by the picture of the house, I drew that red theta. Because that angle right down there will be the same as the angle of depression, right? Those are the same. If we're trying to find that angle theta, it doesn't matter if we try to find the one that's inside our triangle, right? Because that's going to be equivalent to the angle of depression. We're going to think about SOHCAHTOA and decide what part we want to use. So if I'm working with this angle, I'm just going to call this side angle A. Then this is the opposite. This is my hypotenuse. And right here is our adjacent. So using SOHCAHTOA, I have opposite and hypotenuse right now to work with. So I have opposite and hypotenuse to work with without doing any other work. So I'm going to work with sine. So I know sine of the angle I circled is equal to opposite over hypotenuse. So 475 over 850. And then to find angle A, or that theta, I'm going to do inverse sine of 475 divided by 850. Oops, that should say 850. So 850. So then we know that that angle is about 33.97 degrees. So even though we were looking at this picture of the triangle and we were looking at it that way, this angle right here, because of alternate interior, is still considered to be that angle of depression. So our angle of depression is 33.97 degrees.